Now we have our returning champion, Lee Whitcomb from Imagine Communications. He's going to be talking about ST2110 and 2059. And here's Lee to tell you what you've won.
Thanks, Mark. So my talk today here is on a practical guide to secure SMPTE ST2110 systems and what standards organizations are doing to help. When I was submitting my topic here, I think SMPTE was running a contest who could get the longest title. So I was trying to enter that contest. So I figured this was a pretty good entry. Okay, so I'm going to talk about what is a 2110 system, so we're all on the same page. Then look at, there are various standards organizations that are doing some stuff to help, so we'll take a look at that. Then we'll dive into looking at a 2110. And then, because PTP in 2059 is a very critical part of that, then we'll dive into that a bit. For people who attended Thomas and Nicholas's presentation yesterday, which focused on the PTP there, this will sort of supplement that, look at it in a slightly different way, and sort of complement that. So, okay, so what is a 2110 system? So it's basically using the SMPTE 2110 family of standards. So you've got your 10, 20, 21, 30, 40 standards. For your timing, it's going to be built using sort of PTP in 2059 1 and 2. If you're going to be doing redundancy, you're going to be using the 2022-7. We've got the JTM TRO 1001, which is sort of a higher level document defining some behaviors, so you'll be using that. And then for discovery and control of your streams, you've got the AMWA 04 and 05, stuff that Jasper was talking about. So looking at from a high level point of view, what's sort of in the network. So on the right-hand side, you've got your essence switches. So assuming you're doing the -7, you're going to have your primary and secondary. You'll have a control switch for doing your management. Some devices have in-band control, so the management switches will be connected to the data essence switches. Then you have all your media nodes, which is your main processing devices at the bottom. Some of them will be -7 supporting, so they'll be connecting to both switches. Some of them won't support -7, they'll connect to only one switch. Some devices use in-band control, so they won't have a separate management interface. Some devices have out-of-band management, so they'll have a separate connection. So this is sort of what the connections you'll see. As we move out then possibly to the internet, you might have OTT connections. You may have ability for your station engineers and stuff to be able to log in remotely and see the status. So there might be connections there. And often with a lot of new systems, you may have some vendor debugging going on. So using sort of a team view computer or something, vendors can be able to log in from the outside, which from a flexibility and debugging point of view is a very cool thing, but from a security point of view, this just adds more ways that people can attack and get into your system. So even though we often have very sort of physical networks, the primary, the secondary, the red, the blue, and the management, logically these are all often connected, so they sort of form one big network. So we have to sort of be careful from our security point of view that you can sort of get from one to the other. Just diving into the PTP part of that. So typically you'll have, say, a couple grandmasters. They'll typically have GPS antennas connected into your essence switches and then connecting down to your media nodes. So when you're looking at sort of what, at a very high level, what are some of the sort of key areas that we need to secure in our 2110 system? We have our device control. So those are sort of our APIs to sort of control the devices, because if you can get into that, then you can change settings and cause grief. Physically, we have different interfaces. So we have our management interfaces, our different data essence interfaces. We have our PTP system, which we need to secure. If we sort of compare this to our existing SDI systems, I mean, from a physical point of view, they both have the same sort of physical type security. When we look at sort of things where you get, like say, a patch panel or something, with an SDI system, plugging into a patch panel, there's not a lot of damage you can do. But with an IP system, if you have sort of a patch panel where you're logging, or you can connect into the switches, then it gives you a lot more. If you can get from that, you can get into a lot of the other parts of the system. So there's a lot more vulnerabilities that way. So looking at sort of what some of the standards organizations do to help. So the one thing is, in the security challenge here, it's a very large problem. It's kind of like it's almost, you have to worry about sort of boiling the ocean. So what a lot of standards organizations are doing is they've sort of identified different sort of manageable chunks and sort of come up with manageable, actionable solutions to these different areas. So some of the standards and sort of related, some of them are not actually standards bodies, so sort of say related organizations. So one of them is the Joint Taskforce on Network Media, or JTM. So this is a coordination body that sort of coordinates the activities between AMWA, EBU, SMPTE, and VSF. Oops. So the European Broadcast Union, or EBU. So this is an alliance of public media organizations. There's 117 members and I think 34 associate members, so sort of a large group. We have SMPTE, which everyone here should know what that is. So we're basically creating standards, recommended practices for the professional broadcast industry. And then there's the Advanced Media Workflow Organization, or AMWA. So these are some organizations that are in our area that are sort of working on this problem. So what's the JTM doing? So they've been sort of identifying what are some of the problem areas that we should work on, and then reaching out to the different organizations to say, please work on this. So a few things they identified is API security, so for device control is very important. So they reached out to AMWA to say, can you work on this? So this is sort of Jasper's presentation was sort of covering all that work. On PTP, SMPTE has the 2059 standard, so JTM reached out, SMPTE, hey, can you help work on PTP security? And SMPTE said, sure, we'll look at that. And they've also done some work on a vulnerability scanner. So this is a tool that goes through and looks for known vulnerabilities in various products. So they didn't sort of develop it, but they sort of did some research and have sort of selected one as a starting point. So going back a year, at IBC there was an IP showcase. In preparation of the IP showcase, we had a pre-staging event, which we did at the Riedel facility in Wuppertal, Germany. And this was sort of the largest variety of IP equipment we ever assembled in one location. So we had 65 different vendors attending. We had 165 different unique pieces of equipment connected into these networks. So we had so much equipment all interconnected. We wanted to take an opportunity here to see kind of what was the kind of a baseline of where we were in the industry. So with this event, we basically did this first industry-wide vulnerability scan. So we ran this tool across all the different devices. We were trying to look to see, does this methodology work? Is the tool that was selected seem to do an okay job? And is this kind of a good overall approach or not? So some of the goals were basically we wanted to share the results with each of the vendors. So because this is the first time that was happening, we wanted to encourage participation, so we didn't make the results public. The scans were done on each device. We had a sort of separate team that was all by themselves, and the results were only shared with each vendor, so it was sort of kept private. But at least now then that vendor knew what the status of their equipment was. And also, a lot of vendors and users really didn't know where to start, so this now gives us a good starting point. So here's a baseline that we know works, seems to give some good sense of where vulnerabilities are. And then also vendors and users can basically run these same tests in their lab. So as you come up with new equipment, you can update, make sure you're resolving stuff. Or if you're a user and you want to basically say, I bought all this equipment, how is it stacking up? You can run this in your own labs. So that worked quite well. So we repeated that again. We had a 2110 Dirty Hands event in the Woodlands in February of this year. So we repeated that scan. And then there was the JTM tested program, which also was done in Wuppertal in August, and we repeated it again at that event. For that event, we actually had the EBU cybersecurity team come out and run the tests. So in addition to doing sort of the vulnerability scanner, they then dug into some of the results to make sure, are all these results make sense? Is the tool giving like what it considers important? Is it really important? And they're doing some additional probing. If you're interested in trying the tool in your own lab, there's a link to sort of how to configure this and set this up. It's quite easy to be done. The one thing with all the participants, we did agree to sort of share the summary results. So each device was private, but in terms of here are some of the top things that we found, and none of them were overly surprising. So I mean, it was. There's a lot of people using operating systems which are getting sort of end of life or older operating systems, not uncommon, say, with some embedded systems. There's things like HTTP directory traversal, so you can basically, by putting the right commands in, you can basically go to any directory, download the password file, so then you can break that offline. Lots of default passwords, sort of just kind of obvious typical stuff. The one thing we did see, because we ran this scanner 3 times, that the vendors were definitely improving. So where many vendors had more issues, the second time we saw less, and the third time we saw less. So there's definitely, vendors are using this tool, they're improving their products. So the general security of the industry is going up from a vendor side, which is encouraging. What's the EBE doing? So they've run a variety of cybersecurity seminars. If you're interested in attending, it's today in Geneva, so I guess you're not going. Anyway, so they've done some over the last couple of years. Also, the JTM event, they sent their cybersecurity team to assist, and they have several publications. So just looking at their recent publications. So July of this year, just a few months ago, they published a document sort of describing how you would set up a program so that you have, there's lots of security researchers out there, they may find issues with your media organization. You really don't want them to sort of put on their Twitter account, hey, I found an issue with your website. So this sort of defining, here's a process that people can then say, here's an issue, you might want to look at it. They've also come up a month before that, a procedure here that when you find issues with a piece of equipment, you need to have a way to have a conversation with your equipment vendor. So this is some processes to sort of have cooperative discussions between the end users and the equipment vendors. Just before NAB, they put out a checklist here, which Jasper was talking about. So this was a checklist to sort of help guide the discussion again between end users and vendors. So just a way to help frame the conversation. They have the technology pyramid, and they have some other earlier publications from last year on the sort of minimum security tests, which they have this checklist that you can sort of go through. And then they have a services thing here. So this doesn't solve all the problems, but they're just manageable little pieces that sort of help move the problem along or the solution along. So what's SMPTE doing? So at the request of the JTM, a study group on security and PTP was set up. This group was set up with a very focused and sort of small scope because the security problem is large. We wanted to keep this very small in scope so we can get a report done in a timely manner. So that's sort of work ongoing. Hopefully going to be wrapping up not too long. We'll see later on that monitoring is very important as part of our security solution. So not that it was sort of directly created for security per se, but there's the PTP or 2059 PTP device monitoring group that's been set up, and this sort of indirectly does sort of tie into security. And then we have these various sort of interop events, and so where some things were identified as some experimentation, more data need to be collected. At some of the Dirty Hands events, we've run a few little experiments. So with AMWA, they have the interoperability security project with its goal being basically we don't want every vendor doing it a different way. We want to come up with some consistent ways. So this is basically what Jasper's presentation was going over. So the AMWA has the sort of 2 documents. So they have their best current practices, 0003, which is securing the API. So that's a published document. And I sort of won't touch on much because Jasper did a nice job of covering that. And then their other document is 003-002, which is on the authorization. So that's the work that they're sort of, and this document here is sort of ongoing work. So that's kind of that's what different organizations are doing to sort of help us out. As we look at the sort of getting into a 2110 system, so one of the methodologies we can use here is sort of a prevent, detect, and react methodology. So we want to basically figure out, we want to prevent problems from occurring, so we want to use different techniques to sort of secure our network and our systems as best we can. You are going to get attacked, you are going to get breached, so we want to make sure that we can detect if this is occurring. And then you need to make sure you have a plan what you're going to do after you've been attacked or while you're being attacked. So looking at prevention, for a 2110 system, for the most part, it's very much like a regular IT system. So all the best practices that have been developed in the IT industry for many years all can be applied to 2110 systems. So because like our control networks and stuff are all just very, very similar here. So just, a few simple ones here, things like change passwords, as simple as it sounds, that's a very important one. You want to make sure you're restricting access to the right people. You want to make sure you're applying those security patches and upgrades. That can be quite a challenging one for our industry because once you have a system that's working, a lot of people are very reluctant to sort of, I don't want to upgrade it, I want to install the newest patch because it might break my system. But from a security point of view, it's very important that you're sort of updating your operating systems and your software patches because once they come out, attackers know about them, then they know there's vulnerabilities. You want to make sure you're using secure communications, using firewalls. You want to make sure to turn off services. So you should be using things like SSH. So you want to make sure to turn off Telnet, which is not secure. You want to make sure, ask your vendors, have you run the JTM vulnerability scan? For the items that were identified as critical and high from the tool, are you resolving that? Are you following all the AMWA processes? Once the SMPTE study group report is issued, are you following those recommendations? Are you following all the EBE documentation and publications? So these are questions you want to make sure you're asking your vendors. It's nice by having some of these documents produced by these various organizations, at least then you can also have a common document that you can point at. So for detection, you want to have some sort of monitoring system, logging systems. You want to make sure that you're not just doing the logging, because if you log to know that you go back through your logs and you say 6 months ago I was attacked, well that's great, but you really want to make sure that once the attack started, you were able to detect it either in real time or near real time. On the react, you want to sort of have two things. How are you going to respond to the attack? And then how are you going to recover? Depending on what kind of damage configurations were changed, you want to make sure you have a way to recover after the attack. So drilling down now into the PTP system. So you want to do sort of threat modeling. With this, you're basically identifying various attacks. You're sort of prioritizing, enumerating them. Specifically with PTP attacks, some of the different things that the attacker might be wanting to do is they want to change the time in your system. So they could basically take the current time and make it jump forward a year from now. What might this do to you? Well, you have things like your automation playlists that say, play this commercial in 10 minutes. Well, if it's a year from now, it's probably not going to play it. So it can disrupt sort of automation systems. You may have things like, you may have licensed features, and so if the time on the system jumps forward a year, it may say you're no longer authorized to use this feature, and all of a sudden your devices will stop working, or certain critical features that you've paid for will stop working. With changing the time, what you can also do is, instead of just jumping the time, is you could change the frequency. Say if you change the frequency up, say 200 ppm, most devices don't have that lock range. So when you look at the time, you'll see some devices are happily locked, but many, many other devices in your network will become unlocked because they don't have that pull range on their oscillators. So that's what you can do. You can disrupt the time, so you can have the time jump forwards and backwards and forwards and backwards. With 2110, we basically use the PTP time to generate our RTP timestamps. Using our RTP timestamps, this is how we're aligning audio and video. This is how we're aligning different video clips. This is how we're doing our playout delay in our 2022-7 block. So if the time keeps jumping forwards and backwards, then our RTP timestamps are jumping forwards and backwards, and then the receivers and transmitters aren't in sync, and so you may have the receiver, because it expects to play out because its playout buffer, say, set to 10 milliseconds, and the time jumps an hour in the future, it won't be able to play out. So this can cause either loss of our video streams, may cause sort of glitches, audio pops and stuff. The other thing the attacker might want to do is just totally stop your time. So they can do sort of a denial of service attack. They can sort of flood your network, say, with PTP management messages, overload all your devices, in which case then all the devices will then go into an unlocked and free run state. Then all your signals become asynchronous. Depending on the receivers, in 2110, asynchronous is not or you don't have to support that mode. So you may have receivers that can no longer receive the streams. So by knocking out your timing system, again, you can either totally prevent receivers from receiving streams or cause disruptions to those streams. So for securing your PTP system, you need to sort of secure each part of the system. So the critical parts are your grandmaster, then your switches, and then your media nodes. And you want to make sure you have a monitoring system. So you want to have all the devices or all the PTP devices in your network being monitored. So you're getting telemetry back. What is their lock status? What is their grandmaster ID? Once you've sort of finished commissioning your system from my paper yesterday, then you'll sort of have a baseline of what your system should be behaving as. So if you see things like some devices all of a sudden start unlocking, or you see grandmaster IDs changing, or so other changes, this may detect, or this may be an indication that an attack is going on. So it's sort of one of the ways you can sort of monitor and detect. Some areas to sort of pay particular attention for in our industry is there's the 2059 management message. So this is sort of supplemental as part of the protocol, but it's something we use in 2059-2. These management messages are helpful, but unfortunately we'll see in the next couple of slides that things like boundary clock mode is a very powerful tool for defending our network. Unfortunately, management messages flow through boundary clocks. So that's one thing that the boundary clock won't help prevent. So basically launching sort of floods of management messages, you can do sort of denial of service attacks. So it's an area to be very careful as you're architecting your system and looking at the security components. There's a new version of 1588 that's in the works. It's going to be version 2.1. So it'll be out hopefully soon, and it adds some additional security features. So because PTP is used in many different industries, other industries also identified that time is very critical to them, so that's being sort of added to the standard. So starting at the top here, looking at some things for securing your grandmasters. You want to make sure that the management interfaces, the web interfaces, have appropriate controls and access controls, because if you can get into the web interface of your grandmaster, you can change what it's locked to, you can change the PTP domain, you can like wreak havoc on it. So if you can get access to the GM, you can basically take out your entire PTP system. You've got, assuming you're using sort of GPS, you've got the antennas, you need to sort of protect those. One thing an attacker can do is basically have a jammer that can basically, it's doing basically denial of service attack. The one thing with some antennas is that GPS satellites are up in the sky, and so your antenna can basically see if it's seeing signals coming from horizontal or below horizontal, then it knows that this is not a valid satellite. So there are some antennas you can have that have technology built in to sort of make sure that the satellites are up in the sky. Another more complicated but interesting attack can be done as a spoofing attack, where with the jamming attack, you're just basically doing a denial of service. With a spoofing attack, you want to change the data. So you can basically change the time, you can change the frequency. So it's a little more complicated attack, and there are devices and technology that you can put in line with your RF signal to sort of help prevent that. You can be using sort of multiple constellations. So with your global navigation positioning system, GPS is one of them, but there's also GLaSNOS, there's Galileo, and several other systems. So if you use multiple services, it's a way, they're in different frequency bands, as Thomas and Nicholas were showing yesterday. They each operate in different frequency bands that can help give you some extra sort of protection. You can also, from a monitoring point of view, say use something like NTP. NTP may not give you the accuracy that you want, but at least from a sort of sanity point of view, you can compare, is my plant's PTP time compared to an external hardwired NTP time, are the times more or less the same? So that way you can sort of see, did someone jump my time, and sort of do some sanity checks there. Actually, the Department of Homeland Security has a whole little project working on how to get time from multiple sources to sort of help protect systems, because time is a very important service in a lot of industries. Moving down to the switches and the media nodes. So one very powerful thing for securing our switches is to use boundary clock mode. And with so in our 2059 network, it's basically an engineered network. So we're not just randomly having grandmasters appear anywhere. We know these devices are designated as grandmasters, all these other devices are not. So not part of the standard, but what most switch vendors offer is sort of a mode where you can basically say, this port can only act as a master mode. I'll never, if a grandmaster is plugged into that port, I will totally ignore it, or I'll flag it as errors and stuff. So what you want to do is all the ports which are facing towards media nodes, you want to set those to a master-only mode, and then the ports which are facing up towards the grandmasters or through sort of network links up to grandmasters, you want to set them into sort of the regular master-slave mode. So using boundary clocks and this master-only mode is an extremely powerful technique, very simple and very powerful for defending your network, because it will prevent basically rogue masters, which is a big problem. At the media node level, you want to set it to sort of slave-only mode. because you don't want your media nodes to become the grandmasters. They probably don't have the correct oscillators and everything. It may not improve your security greatly, but when it comes to monitoring, it just helps prevent any sort of false alarms. So what are some key takeaways here? So these various standard organizations and related organizations are working on practical and actionable solutions. They're not sort of solving the entire problem, but they're each carving out little sections, so they're helping sort of moving the industry forward. The critical areas that you sort of, as you're doing your threat assessments, you want to look at is your device control. You want to make sure that's done right, so you want to be using all the AMWA standards there. You've got your management interfaces and your data interfaces. You want to make sure that you're securing those properly. You want to focus on your PTP system because it's one of the core building blocks of your infrastructure. If PTP has a problem, your whole infrastructure has a problem. For your 2059, you want to make sure you're using boundary clocks. You want to use that role master. You want to be verifying grandmaster IDs are correct on your monitoring systems because that's how you can detect rogue masters. And all the sort of basic IT practices that your IT department already has, you want to apply those to your 2059 systems and your 2110 systems because they have lots of good techniques that have been built up over years and years and years, and you want to sort of apply all those into our systems. You want to make sure you have that monitoring solutions so that you can detect when your system is changing, when you're under attack, so that way you can basically have a plan to sort of react and resolve. Thank you. Any questions?
We have time for a couple of questions if anybody has any. No? Thank you, Lee.